In this video, I'm going to show you how to use Gaussian elimination, or another thing I'm thinking that's getting it to that row reduced form, or really getting into the identity matrix. And that's when you get into the ones and zeros. So the goal here for every one of these problems is to make them become their identity matrix. And in this case, I'm only going to make you do by hand the 2 by 2s. So I want to make this 2 by 2 right here. First off, the augment looks like this. -5, 4, 2, 2, -5, 6. I want to make that matrix become this right here. Remember, I want this part, the constant part of this matrix, to be 1, 0, 0, 1. And it's going to have the solution sitting over here for x1 and x2. So that's the goal. Let's go find that. And we need row operators to do it. And remember, our 3 row operators are, we can either switch rows, we can add and subtract rows, or we can multiply by scalar numbers to get rows to do what we want them to do. So in the first thing I want to looking for is I want to get a 1 on that main diagonal. Because there is not a 1 there, the easiest thing for me to do is going to be able to divide everything on the first row by the number sitting here in this first column. So I'm going to divide everything in the first row by -5. Because I want to put a 1 on that first column, in that first spot. So we'll say multiply by -1/5. And we multiply by that number there. It's going to introduce fractions here, so be careful with that. So here we go. We have -5 times a -1/5 is +1. 4 times a -1/5 is a -4/5. And then 2 times a -1/5 is a -2/5. First row. Second row, I'm going to leave that exactly the same as it is right now, which is a 2, a -5, and a 6. Now, next step is to get a 0 underneath this 1. So to get a 0 here, I can multiply this row by 2, or -2, and then add it to R2. So it looks like this. Keep the first row the same. So I get 1, -4/5, -2/5. Now, I'm going to multiply this row. I'm going to multiply the first row by 2, or -2, -2 R1. I'm going to add it to R2. That'll become the new R2. So -2 times 1 is a -2, plus 2 is 0. -2 times -4/5. That's negative, that'll be a +8/5, plus 5, plus a -5. Well, problem with that is that now, this right here, I need to make this right here, I need to multiply by I need to add a number with fifths in it to a number that doesn't have fifths. I need to turn this to fifths. So if you know how to deal with fractions, this should be a -25/5. That is a -25/5. And I'm going to multiply -2 times -4. That's a +8. So that's 8/5 plus a -25/5, right? So 8/5 plus -25, or -25 plus 8. That'll be equal to a 17/5. -17/5, I'm sorry. Then I'm going to multiply -2. And again, I have that same problem right here. I need to change this 6. That is 30/5. And again, these are easy to see that they're actually what these numbers are. -25 divided by 5 is a -5. 30 divided by 5 is 6. So I'm going to add, now, -2 times -4, +4. That's +4/5 plus 30/5 is 34/5. Right? Now, I hate dealing with fractions. I'm sure a lot of you don't like them either. So what I can do next is this. I need to get a 1 right here. But before I do that, I want to make this, I don't want it to be a fraction. So I'm going to multiply that row by 5 to clear that fraction out. So here's what I get. 1, negative 4/5 at the top, negative 2/5 here. I'm going to multiply that bottom row by 5, or negative 5. I want it to be a positive, well, it's 5 in general. So 5R2, and I get this. 5 times 0, 0. 5 times the negative 17 fifths, negative 17. And 5 times 34 fifths, positive 34. So I just got rid of the fraction by multiplying by 5. Next up, now I see that I need a 1 in this position right here. So I can divide that by a negative 17. And that's nice because both these are divisible by 17. So I'm going to get this negative 1/17 R2. And that's going to give me 1, negative 4/5, negative 2/5 at the top. Don't touch that row. Bottom row, I get this though. Negative 1/17 times 0 is 0. Negative 1/17 times the negative 17 is positive. Negative 1/17 times 34 is a negative 2. So here, if I were just trying to solve this and I can see that from multiple choice, I can see that my x1 has to be negative 2. I could go back and then back substitute if I want to, but I'm going to finish this off. I'm going to finish it off by doing this. Now I need to get a 0 right here, right? So to get that 0 there, I need to multiply this row down here by a positive 4/5 and add it to this row up here. Because we get bottom row does not change. So you have 0, 1, negative 2. I'm going to multiply the top row by 4/5. Multiply that row by 4/5, so it's 4/5 R2 plus R1. Dash R1. So again, 4/5 times 0 is 0, plus 1 is 1. 4/5 times 1 is 4/5, plus a negative 4/5 is 0. 4/5 times 2 times the negative 2 is a negative 8/5. Plus a negative 2/5 is a negative 10/5. This is a negative 10/5. Now, negative 10 divided by 5 simplifies to just 2 though. So that's a negative 2 sitting there. So I can see now that my solutions from the reduced matrix is going to be negative 2, negative 2. The answer here is B. Now, honestly, this is the way I want to see you do it. And on your test, I'm going to force you to show me that you know how to do some of this stuff. But if this was just a multiple choice part of the test, all you really need to do is take your solutions and plug them in and see which ones actually made it true. But because I'm showing you how to do this through this Gaussian elimination method, you need to be able to do this at least up to the point to where you can back substitute. I can back substitute here at this stage, or I can continue it all the way out and get it to reduced form.